Hi again. So today we're talking about systems of linear equations through substitution. So it's still the same idea that we are trying to find out where two lines, straight lines, intersect. Well, sometimes it's not as easy to graph it. So the information that you saw in the last video, if you had something like 0.9 for your x value and 0.32 for your y value, you wouldn't be able to see that very accurately if you were to graph it by hand. So today we're gonna walk through substitution. Well, a lot of times people say plugging in place of substitution, but we really want to call it substitution. It's the more technical way of saying it, or the more mathematical way of saying it. So, if you've been given equations like this for a while, where you know your x value, you have to substitute it in, and so wherever there's an x value, we are going to replace it with 2, and we're going to put parentheses around it, because otherwise, if you just replace the x with 2, that's very different and it looks like 32 as opposed to 3 times 2. So make sure that you're putting parentheses around what you're plugging in. So in this case, y would equal 6. X is 2, y is 6. Well, now we have systems of linear equations. Well, if we know what y equals or what x equals or whatever letter you have, so we know in this case y is equal to negative 3x minus 9. We can go in and replace the y value with that. So in place of y, we're going to put 3x minus 9 equals the rest of your equation. Well, from here, we just want to look, can we combine any like terms on the left side or the right side? And the answer would be no. So my thing is, if I can get rid of negative x's, I'm going to do that. So to get rid of a negative 3x, we can add 3x to both sides. Okay, that cancels. We're left with a negative 9. So 2x plus 3x gives you 5x. Everything else comes down. Well, I want to get rid of that positive 1 because now that we have the x's on one side, we want to get the constants to the other. Okay, so negative 10 equals 5x. To go backwards, we have to divide by 5 since we are multiplying by 5 to go forward. So negative 10 divided by 5, that gives you a negative 2. Well, it's not enough to know your x value. Think about the graph that you saw in the previous video. You have to know where it is that they're crossing. So we need to plug this x value back into either one of the equations. It doesn't matter because they're still going to cross at the same place. So I'm going to use the bottom equation. You could have used the top. And we're going to plug in our negative 2 for that x. So once again, you have to put parentheses around what you plug in. 2 times negative 2 is negative 4. And we're going to simplify that, so y equals negative 3. Now our last step is to put it into a coordinate pair, because once again, it's on a grid and it's where the two lines are crossing. So negative 2 comes first, x before y, and then negative 3. So this is our final answer for this problem. This is where they intersect. We're not always going to have equations where y is by itself. So in this case, we have to get y by itself first, or x by itself. Because again, it doesn't matter which letter you get alone, you just have to isolate one of the letters. So I'm looking at the top one. That looks like it, I mean, we could do it for x or y, but it would be a little bit more work. I'm going to do the bottom one because do you see how it would be easy to get x alone? We just have to add 3y to both sides. So in this case, x equals 3y. It's a negative 14, so minus 14. Well, if we know what y equals, what x equals, we can replace that in the other equation for x. So I'm going to write this equation, but I'm going to plug in what x equals. So remember, with parentheses, that is important. Okay, so negative 2 times our x value plus 4y equals 18 because nothing else changes yet. Okay, so I'm going to multiply that negative 2 all the way across. So negative 2 times 3y is a negative 6y. Negative 2 times negative 14 is a positive 28. Everything else comes down. Okay, we're going to combine like terms. Negative 6y's plus 4y's. You now have negative 2y. Again, everything else comes down that you haven't used. And we're still going to get y by itself, so we can't combine anything else. We're going to go backwards. So we have to get rid of that positive 28. So we're going to go backwards and subtract it. 18 minus 28 gives you a negative 10. And last but not least, since negative 2 is multiplying to y, we have to go backwards and divide by negative 2. So in this case, y is a positive 5. Well, again, we're not done with that because we need to know what our x value is. So you can plug it into either one of the equations above. I'm going to choose the bottom equation. Again, you could do either one. So I'm going to plug in my y value of 5 in for y. Everything else is going to stay the same. Well, we can simplify that. Negative 3 times 5 is a negative 15. And we want to get x by itself, so our last step is to add 15. I'm not sure how that black mark got onto the negative 14 before. I'll have to figure out what I did later. So negative 14 plus 15 gives you a positive 1. So we have our x and y value. We're going to put that into a coordinate pair. So x before y gives you 1, 5. All right, I'm going to give you one more example. It's a little bit tougher this time, not too bad. But once again, we either want to get x by itself or y by itself. Now, my thought process is if I try to get y by itself in this second equation, that means I'm going to move this negative 7x over. It's going to be positive 7x now. Well, if I have to divide by 3 to get y by itself, 7, you can't divide it evenly by 3. 18 you can. Well, if I want to get x by itself over here, if you divide by 7, you're eventually going to have to do that. That doesn't go evenly into the other numbers. Well, looking at the top equation, same process. If I want to get x by itself, 4 isn't going to go into 1 evenly or 6 evenly, but I can get y by itself. So that's my thought process in trying to figure out which letter do I want to get alone. So to do that, I'm going to start by subtracting 4x to get y by itself. Now remember that negative stays with y. So we have that negative 4x plus 6 because it is a positive 6. Now we can't have a negative in front of y and call it good. It's not alone yet. So technically there is a 1 in front of y. It's a negative 1. I'm going to go backwards and divide by negative 1. So those negative 1's cancel out and we have negative 4x divided by negative 1 becomes 4x. 6 divided by negative 1 becomes negative 6. Well, now we have a letter by itself and we can plug it in to the second equation. So everything else is going to stay the same. Negative 7x stays the same. Plus 3 stays the same, but we're going to plug in that y value. Again, everything else stays the same. Well, we want to simplify this. So once we bring down the negative 7x, I almost forgot that step, 3 times 4x becomes 12x. 3 times a negative 6 becomes negative 18. And we bring down the negative 18. Well, we can combine like terms. Negative 7x plus 12x. Well, that gives us 5x. And I'm going to just add this 18 to both sides. Hopefully those 2 steps in 1 isn't going to be crazy. That cancels. And this turns into 0. Well, we want to get x by itself, so we're going to go backwards, divide by 5. So x equals 0. Well, if we plug that back in here, if you notice, if we plug it in for x, that cancels. We're left with negative y equals 6. We want to divide by the negative 1 again. And so y equals negative 6. Our last step is to put it into a coordinate pair. So, oops, 0. And negative 6, and that's our final answer. So let your teacher know if you have any questions about substitution. But again, it's just to see where the lines intersect. So thank you very much for watching, and we'll see you tomorrow.